Okay, today I'm going to talk to you about radio waves. I'm going to show you how radio waves can be generated and received and the different uses of radio waves as well. So first of all, let's have a look at radio waves in regards to the rest of the electromagnetic spectrum. So just like the rest of the electromagnetic spectrum, radio waves are transverse waves that transfer energy. As you can see, compared to the rest of the electromagnetic spectrum, they are the waves with the lowest frequency. That means the fewest waves passing a point per second. And also, they have the longest wavelength. Remember, wavelength is just simply the distance between the peaks of two waves. Now, just like the rest of the waves in the electromagnetic spectrum, in a vacuum, they travel at the speed of light, which is around 300 million meters per second. So, we're now going to see how radio waves can be generated. So let's imagine we've got a radio station that are transmitting their show across the nation. Now, in order to broadcast that signal, first of all, they need something called a transmitter. Now, a transmitter is made by this here is an oscilloscope that just shows we have an alternating current. So in order to generate this radio wave, to transmit it across the nation, we need a transmitter, which involves an alternating current being supplied to an antenna. Now the antenna is made from a conductive metal. The alternating current, which is supplied to this transmitter, causes the electrons within the transmitter to oscillate. Oscillate means to move backwards and forwards in a kind of consistent rhythm. Now, as that happens, it causes the generation of a radio wave, which transfers energy away from this transmitter. Now, let's imagine at the other end, we obviously need someone to receive the signal in order to listen to the radio show, which is being broadcast. So at the other end, we have a similar kind of setup, but instead of a transmitter, we have a receiver. Essentially, it's the opposite idea. Instead of introducing an alternating current to make electrons oscillate, this radio wave, as it hits the receiver, it causes electrons to oscillate, which are in the receiver. This in turn generates an alternating current. So this is how someone would receive that radio signal, which then they'd be able to listen to this particular broadcast over here. So the energy is being transferred from this transmitter to this receiver. And radio waves can actually be transmitted through the body without being absorbed. So what we're going to do now is we're just going to have a quick look at a few different uses of radio waves. So number one is long wave radio. Now these long wave radios have wavelengths of 1 to 10 kilometers. So the distance between the peaks of two waves are really, really big, between 1 and 10 kilometers. Now the reason why that they could be received halfway around the world from the transmitter that it started off with is because these waves can bend round the Earth's curved surface. So they're excellent for transmitting information over a very, very long distance. We also have shortwave radio. So again, it's the radio waves are made in the exact same way, but only this time the waves are shorter. So the wavelength is shorter, 10 to 100 meters instead of 1 to 10 kilometers. Now these again can go receive the long distance from the transmitter, but for different reasons. It's because these are actually reflected by the atmosphere. So these are both dealing with really, really long distances. In order to transfer data over a very short distance, we can use something called Bluetooth. Now all Bluetooth is used for is for transferring data wirelessly over a short distance. Now the final one we're going to look at is TV and FM radio. So compared to some of these, for example, we're dealing with a much shorter wavelength. Now, this TV and FM radio, basically to get reception, the receiver needs to be in direct sight of the transmitter because the signal doesn't bend or travel far through buildings. So the receiver needs to be in direct sight. Okay, so that basically, guys, is an overview of radio waves, how they're generated and received, and the different uses. Thank you.